Within this presentation, I will prove to you that reliable AI vision works without laboratories, preparation, and environment adjustments. Quickly to us, so we are doing vision AI technology over 7 years and are Fraunhofer spin-off. In all cases where we have said it will work, we were successful and we are bootstrapped and since the second year profitable. So we have shown professionality over the last years. We do stuff like this. This is an example from one of our customers, Seco. So it's one company out of the Sandvik group, and they have to do end-of-line testing of these parts. So these parts have a large product variety. So there are over 2,000 different products, and there are also many different types of defects. The AI is working in machines like this, so that's an end-of-line testing. And we were selected out of 45 AI companies from Seco and are now the number one for Vision AI for Seco. So what we are doing is we do something like pick and place. So you have to take it out from the crucibles. Then we do a testing for the defects. You have to test for defects like this or like that, and then repack it. As you have seen already with this case, it would be very hard to do this with classical machine vision. So because they need a very stable environment. So factors such as lighting, positioning, background, and variability of the object strongly influence the result. So the conditions must remain the same over time. So for both for the object and the environment, and you have a high risk of incorrect analysis due to uncontrolled environmental changes. So, and also this cannot be quantified. It leads that you do have a high effort, so in cost and time, for the scene preparation and for the creation of the algorithm. On top, it's in sequential programming. It means you need a very high level of expertise of the skills. And possible sources of error due to variables such as the light movements or other change conditions are very likely. So on the other side, you have Vision AI as a new technology, and it has an increased accuracy and stability in complex scenarios. So you can solve cases that were unthinkable before. It reduces expensive hardware for image acquisition and saves time in setup and maintenance. And which is a very strong fact, you can continuously learn and improve from new data over time. But also this technology has downsides. So the technology itself is very complex. So often it ends up that you use low performant open source solution. So we are often asked for the YOLO model. So the YOLO model is not really applicable for repeatable and reliable analysis in production. So you have a higher initial development and implementation costs, therefore, and often the layer structures don't fit the application because most also AI experts don't understand the power of layer structures and how important it is to control them. You depend on a rather large amount of data, and you have a limited robustness for data outside the training area. It means images which look different and are not in the training data set, which also holds for classical imaging. However, here it's unpredictable how AI will behave. So we have overcome the buts because we have concentrated over the last decade already to really handle these cases. So I will show to you that DenkNet works with minimal effort. It does not need know-how, that it does not require laboratory environments. It always works well, it's stable, proven mass production, and it's cost efficient. And I will go through every point and will explain to you why this is like this. So let's start with the minimal effort. So for this, we have developed the DENK Vision AI Hub. It's a platform technology, and it's only done because that you get an easy access to our leading technology. So you don't need any know-how. You just need some clicks to set up the cases and image analysis. So really everyone can use it. It takes only a few minutes to train an AI, and also it works up to 15 images, which I explain to you later. I will prove this with two different applications. So the first one is, as you can see here, to find eyes simply with smartphone images and divide them into the 4 different groups which are existing. It's very easy. So the first is you set up a model. It's always the same for us. So you just give a name. There's no decision. And in this case, you have to create some labels. So white, black, and so on. And for the training, then you annotate the folders. In this case, for example, in this all dark chocolate. Here is the chocolate around with nuts, also, and so on. And then you simply press play. And that's our motto. That's all what you have to do, and it's as easy. So we handle all the rest in the backend full automatic. The next example is a bit more industry. As you can see here, this is an example where you see already that there's no real laboratory conditions. So you have here the shadow of the border. So that's a chest full of these metal parts. And the metal parts itself are also very, let's say, diverse. And the task is here to count them and to pick them out. So, and it's already as easy. So what you do is you set up, again, a model, in this case, an instant segmentation. So you want to find it pixel accurate. I'm sorry, it's a German word. So it's a metal part. And then what you do, you don't want to annotate here the whole box, which is, of course, possible. But here I show to you, you simply choose a local region of interest. Local means the AI knows, okay, I have to apply what I learned here on the whole image. And then you can use our one-click tool. You simply annotate the this part and then save and next. And then you have to repeat this 10 times. Yep, that's it. So I think I have proven to you that you can generate an image analysis with Vision AI technology with very minimal effort, and the logic is always the same. So we do not need laboratory environments, and this is because over the last years we have developed an image generation. So we always say that you can train an AI with 50 images. That's actually technically not true. We also need 60,000 images or something like this, but we generate them artificially. And that's kind of advanced because you have to be very careful what you are doing. And also you need the technology in the back end to annotate or to generate these artificial images. Again, to this example, that's are the training images. However, in reality, it can look like this. So completely distributed, only one, this is a problem, only one piece. However, you always train with a lot of pieces. And there is a complete different size of this objects. So it is always difficult to decide what can you simulate and what can't, right? So, but we have a lot of expertise here and have kind of decision criteria where we know what is he annotating, what is changing. So we're looking for the object, which is called the positive area, and the surrounding, which is called the negative area. So, and based on this, we are able to overcome also these changes and to make the AI more stable against data which is outside the training data set. On top, we simulate a lot of stuff like the lighting conditions because they can change a lot. So a good example is this. We have a customer who has trained all street relevant objects. Here it's about 1,000. And it's quite nice because the objects are more or less clearly defined and the background is always changing. So you can generate here quite a lot of artificial images where you can handle then this application. Here you see the training images, and you have examples where you only have two examples. And first of all, we have to deal with this imbalance of the data set, which is not so simple. And second of all, of course, you cannot train an AI with 17 images in order to find this in a real life conditions. So you have to generate artificial images, and that shows to you that it really works. It always works well. This is a bit more technical. So I recently had a presentation at VDMA, also at EDS, and here I try to explain that vision AI is not really artificial intelligence. It's only statistical mathematics. So it's not intelligence at all. Nevertheless, it's a strong tool. But the secret is all about the used math and how you set it up. So the trick is this layer structure. So if you have a good layer structure which fits to find faces, you cannot use it to count fishes in a production. So therefore, it's quite important to handle these layers architecture. And that is one of our USPs and also one of the cases why we have founded the company. We do have an automatic search for an optimal network architecture, which we call Denk Network Architecture Search. So it means we not only adapt the parameters, we also adapt the math to the problem. So of course, it's not the perfect solution because the parameter amount is way too high, but at least it's a solution which fits much better than a standard layer architecture. On top, we do have a very dynamic training. So with several AIs in the competition in the background, which the end customer don't see, but it offers us a possibility to, let's say, play a lot around without messing something up. So I don't go into detail in this, but it's kind of really a key to control this. DenkNet is stable and proven mass production. We have shown this way more than 1,000 cases in the industry, which are running stable over years. And it's also because of technology. So what we have concentrated is to generalize our solution. It means that, of course, what I explained before, we simulate conditions that can usually occur in production, which are not in the data set. Like lightning is a very good example. If someone goes in front with a red shirt, you change already the parameters because of the reflection of the red shirt. In classical algorithm, they struggle a lot. In our case, we try to overcome this with simulation. On top, we know issues like drifts or atypical behavior of AIs, which start to occur in other solution, and we prevent them because we understand very detailed as a deep tech company what's happening there. On top, we try to prevent operation errors by humans during the training, which is quite hard and tough, but nevertheless, also there we try to handle stuff in the back end where we know, okay, that must be a failure of the human. With all these things which we are doing in the back end, we at the end have a very good generalization for a stable mass production. And that's where we are really focused, that it runs stable in the production and can handle issues which happens then. And also here again, I want to prove this with an example. It's a company which is looking for defects on sofas like this. And there's never ever the same conditions because they do have a smartphone. And also they don't want to train with million images. And it works because we do handle all the surroundings and stuff like this for them in the backend. And finally, it's cost efficient. And why is DenkNet cost efficient? So first of all, which is one of the most important reasons to use Vision AI technology, is the project time for creating the image analysis is greatly reduced. So from 2 weeks to 2 hours. Of course, there are lots of cases which you can solve also with classical algorithms. Very good. So I don't want to say that you always have to use Vision AI technology, but be aware that you can save a lot of time, even if you solve very simple cases. It saves expensive personnel with expert knowledge, because what you have shown, it just point and click. You don't need expensive hardware for the training, because we offer this as a service, and you save through simpler hardware for image recognition. As an example, we always do something which is called proofing. So we reduce the image size as long as the AI still performs with a high performance. And we see very often that people uses whatever K cameras, and we reduce this down to several hundred pixels. So this high-end hardware was not needed in this case, because the thinking is different. You don't need to have this super accurate imaging if you probably want to find some defects. If you want to measure, you need it still, but nevertheless, you can reduce also the hardware costs. And finally, ask us for an offer. So I want to conclude my talk with what can you do with this technology. So you can do an image classification, you can do an object detection, you can do an anomaly detection, segmentation, instant segmentations, text reading. So it's already trained, but you can also train it further. You can read codes, QR codes, barcodes, and a brand new technology, matching. We have lots of ready-to-go solutions and further end-to-end AI technologies, which are, however, very individual. I want to pick out 2 examples in order to go a bit more in detail. The first is the OCR. We have a very well-trained OCR network, which is super powerful. It often does its job. Nevertheless, you can also further train it very easily with the same logic with like all other technologies. So you simply say what it is, press play, and then it trains further. And at last, I want to advertise a new technology. Here you see an image of 2 different stations of 2 different blocks, and the AI don't find any match, so which is its task. And if it's the same block, it finds a lot of image matches. So it's called, we call this DenkMatch AI, and you can track or find same parts on complete different images. So as a conclusion, I have shown to you that DenkNet works with minimal effort and does not need know-how. It does not require laboratory environments. It always works well. It is stable and proven in mass production, and it is cost efficient. Thank you very much.